Hi. Every now and then something comes along that just seems super cool and you just got to have it. And that's what's in this package. It's not a piece of NuTone equipment. It's not a piece of music and sound equipment. It's something I saw a review of on another YouTube channel, and it just kind of screamed out to me, hey, I want one of those. Is it something I really need? No. But it's really cool, and sometimes you just gotta have it. This came all the way from the, what was the name of the place? It was the New Beautiful Life store in Shenzhen, China, and it's a brand new model. They call it a digital oscilloscope. It's actually a combination oscilloscope and multimeter. And I thought I would buy one because it just seemed like the thing to do. It came in yesterday. It took about 10 days to get, which is not too bad. And when I saw the other review on the other YouTube channel, which I'll put a link to down in this video's description in case you want to see it, or maybe one of those pop-up things up here, I ordered it immediately. So I got it at the introductory price, which was good. And they weren't out of stock. I don't know whether they're out of stock now or not, but they could be, because this kind of stuff goes pretty fast sometimes until they catch up. So go ahead and open it up here. This is not a full-on review like the other guy does because he's more set up for that than I am, but this is just something that I thought was cool and would share because maybe there's a few of you out there who could use something like this. So it comes in this nice little carry pouch thing. We'll unzip it. You get all kinds of stuff with it because everybody likes lots of accessories. So you got the carry pouch. Seems to be pretty well made. Here's the unit here. Of course, the first thing you have to do, here it is here. The first thing you have to do is you have to peel the protective plastic off the screen because that's the most satisfying part sometimes. And what do you get with it? You get a user's manual, which we're going to talk about a little bit in a bit. You get a USB cable, and I think, if I'm not mistaken, I'm not sure, I think it's rechargeable. I don't think you have to, I'm not sure if you can put conventional batteries in it or not, but you get a USB charge cable. You get what I think is I'm pretty sure, you get a temperature probe for measuring the temperature of things. You get a pair of multimeter test leads. And we'll see if the other fellow was right. He's very hard on quality of things. He wants everything, he wants everything to be Hewlett Packard or Agilent quality at a reasonable Kmart price, and that's not always the case. These aren't horrible. They're not silicone. They're probably plastic, but they're not bad. They have good handles and they have covers for the tips. And one of the things that is important, which he pointed out, is when you have test probes, you want the points to be really, really sharp. Because sometimes when you're measuring, you've got to push the point down through the oxidation on the solder to get a good measurement, and these seem to be reasonably sharp. They come with covers, so when you're not using them, you put the cover back on. One, so you don't stab yourself, and two, so you don't dull it on something accidentally. And then, of course, here in your little Ziploc bag, because you'll want to keep those, these kind of things you just put back in the pouch because those are very sturdy. But here you have your oscilloscope probe here with your BNC connector on the other end. It's got a ground wire here, and then you've got little color rings and other identifying things that you can snap onto it. So if you had, it's the idea of this is if you had a 2 or 4 channel scope, you would put different colors on different probes so you know which one you're using. And a little adjustment screwdriver, because I think this is, I don't know if this is a times 10 probe, which we'll talk about briefly. This is not a full-on review or tutorial on how to use an oscilloscope. It's just me playing around with something that I thought was cool. But I believe that there is a trimmer on this somewhere, and you can set it so it's compensated for. So here's the unit, and I guess the first thing we should do is we should turn it on. Now, let's stop for a moment and talk about something. Here we have the user manual, and the user manual is exactly what it says. It explains to you how to use the tool that you just bought. There seems to be a trend in the world, I think it's always been this way, but more so in the last maybe 5 or 8 years, as equipment has become more and more reasonably priced and does more and is more complicated to use in some respects. People don't want to read the manual. They assume that you should be able to pick this up and it should be designed in such a way with its ergonomics and its thoughtful design and its logical design, and immediately start pressing buttons and know how to do everything. That's not usually the case for most people. If you want to get the most out of this, if you really want to use it well, you need to read the manual, because the manual is going to help educate you on how this works. Now, the other fella, he doesn't like to read manuals. He assumes that he should, and he has vast knowledge, especially with oscilloscopes, but he assumes that it should be all intuitive on how to use it, and that's not the case for most people. And in his video, there were times that it didn't do what he thought it was supposed to be doing, because basically he didn't know what to do because he didn't read the manual. So take a few minutes and read the manual. It's not only for like bench equipment, or you buy a new appliance, or you buy a new phone, or whatever it is. When you buy a new car, I think most cars still come with owner's manuals, or you can have the dealer get you one, or you can probably go on the manufacturer's website and download it or something. The owner's manual for my car that I drive, which is a 2015, so it's not super new. The owner's manual, I don't know, it's got to be like 300 pages. You know, it's a small format kind of thing, anything. But if you really want to understand, especially as cars have more and more electronics and more advanced features, if you really want to understand how to use it all and adapt how you drive to it, read the manual. So that's what I'm going to say here, read the manual if you get one of these, because you'll learn a lot. The first thing we need to do here is we need to figure out how to turn it on. So here we have a red button with an obvious on-off thing, and I would guess that you have to push it down. Oh, by the way, this is a Zoe or Zoya, or I don't know, however you say that, model ZT702S digital oscilloscope, and it turned on pretty fast, and you can see it's got a little oscilloscope display right there, and it shows a single trace. So now maybe you can see better. Here's our display. Here's our, what would be our graticles, the rectangular grid. And here is our line for where the signal will show up. And then you have a variety of buttons. You have a mode button, and I haven't read the manual yet. I just opened this now for this video. And I will read the manual. I'll probably do that this afternoon or tomorrow. If you push this, it switches over to the multimeter mode, and if you push it again, it goes back to the oscilloscope mode. And then you seem to have some function buttons here. You have F1, and I think the function buttons have to do with these labels up here on the screen. See, this one, F4, switches between AC and DC inputs. F3 is your trigger. F2 is to move it. And F1 is your horizontal and vertical, I believe. But I haven't read the manual, so I don't know. So I think you do this, and then you use the arrows, perhaps. Or maybe not. Oh, when you push menu, you have a menu button. You know how much I like menu buttons. And then you can switch. So you have your coupling, AC or DC, trigger mode, auto or normal, slashing weight. You have your trigger, rising or falling, your probe inputs, so it's ×1 or ×10. It's all of your standard oscilloscopy kind of stuff. Now, if you don't know how to use an oscilloscope, if you've never owned an oscilloscope, but maybe you really want an oscilloscope, but you don't want to spend, you can buy a pretty decent 2 or 4 channel oscilloscope nowadays for about $400. And I'm not going to say how much this was until the end of the video. But if you don't want to spend $400 and you're only going to use it maybe 10 times a year for something really, really, really simple, then this would be a reasonable choice. It's not going to take the place of a $400 oscilloscope, and it's certainly not going to take the place of a $2,000 or a $4,000 oscilloscope, but not bad for the money. Now, the other thing about this is only a single channel oscilloscope. It's only got one input. It's not a dual channel. And no, I don't know how to get back to the standard whatever it was here. We seem to have lost our trace, but again, have to read the manual. And we're going to hook it up and see. So to use the oscilloscope on the top here, you have a BNC connector, and that's where the BNC connector of your oscilloscope probe would be connected. Now this goes in here and it sort of twists and locks. And the other fella, he had a really hard time with that, and I don't know why, because while it's recessed, and that makes it a little trickier, and they made it recessed so it protects the jack and you don't drop it on the ground and break it. But I don't find this particularly hard to deal with. It locks in pretty well. I do notice, and he talked about how this swivels, which is good because you're less likely to break the cable when you do that. So, and there's our trace back again, so it seems to be moderately happy. And I believe that if we open this little port on the side here, this is where our USB charging cable plugs in here. So you can plug it into a USB charger or your computer and charge up the battery. I think it has a lithium-ion battery. I will look at that a little bit and see what that's all about. But these jacks here, these are to set the compensation on the probe. And I believe, let's see, ground and square wave. So you would clip this on here. This is something that almost all oscilloscopes have because you need to compensate for the probe. And if you hook the probe on the other one and you make it stand up again like that, let's see if we can figure out, maybe without reading the manual, what to do. So I read the manual a little bit. I have the probe hooked up to the built-in signal jack on the side. What we show here is internally it creates a square wave, which is what you're looking at here. And then if the square wave isn't truly square, which square is self-explanatory, straight up, straight horizontal, and straight back down, if it's peaked up or drooping down, then you adjust the compensation on the side of the cable to make sure it's square. That way your probe is matched to the oscilloscope. It's very simple. We're going to move this over to the RF workbench here in a second, but before we do that, let's talk briefly about some of the basic specifications. This is not going to be super complicated because many of you have no idea how to use an oscilloscope, and this is not a tutorial. So this has a built-in bandwidth of 10 megahertz. That means that it can measure signals from 0 to 10 million hertz. Now, my day-to-day oscilloscope that I use on everything is 200 megahertz because I use it for alignments and things for tuners, and it needs to be higher than that. But for most hobbyists and occasional users, 10 megahertz, plenty. If you're just working on basic audio stuff, like say maybe your hobby is you like to work on more vintage audio amplifiers or receivers or something like that, 10 megahertz is plenty. It has built-in sampling. It is a digital oscilloscope, so it can store signals, it can store displays, it can do all of those sort of things. It has, for measurements, it'll do period, frequency, peak-to-peak values, minimum value, maximum value, effective value. It can do auto triggering, rising edge and falling edge triggering. It will do everything that a basic sort of more advanced, a beginner to slightly more advanced beginner would possibly need for something like this, and it's very usable. So when I used to do lots and lots of field service calls, it would have been great to have something like this in my van for the occasional time that you would need to use it, because it would just be super convenient. It does have a built-in rechargeable lithium-ion battery. It has a battery indicator, which is now going to show one red stripe left, which means it's starting to run down. So I'm going to pause the video a second, change it over to the multimeter mode, and we'll do that, and then we'll go back to the oscilloscope mode and feed a signal in so you can see what it looks like. So we're on the RF workbench now. I have it hooked up to my signal generator, and what you're looking at here, this is a 10,000 hertz sine wave. And once you feed it in, you can adjust the vertical and horizontal to see more signal or less signal. You can change the vertical to keep the whole signal on the screen. So if you have a little tiny signal, you can make it, see, now we're down into the noise. Perfectly usable. Now, the display is small, so the resolution of the signal is not huge. It's not like looking at it on an 8 or 9 inch screen, and the resolution isn't as high. But if you're in the field and you need to quickly hook up to something to see if there's actually a signal there or not, this would be ideal. Also, if you're a hobbyist and you're just doing something really simple, maybe you're adjusting a power amplifier and you're adjusting it to set the clipping level of a signal, you can certainly use something like this. It's certainly good enough for something like this. If you're into really high-end electronics or really super high frequency stuff, no, it's not going to do it for you. But for this, it's not bad at all. So it's just a fun, for me, it's almost a toy, but for some people it would be very usable. So let's take a quick look at the multimeter part. We'll go ahead and get our probes that came with it. And again, not bad quality for what you paid. Talk about the cost at the end. Unknot them here a little bit. They always come with these sort of protector caps, which if you leave the probes plugged in all the time, you don't really need to always use. But if you store this away, put them back on. Don't just toss them away, because that keeps dirt and stuff out of the ends of the jacks, and that's good. So the black one goes in the COM, or the black jack, like this, and the red one goes in this one right here. And we'll switch the mode over to multimeter mode. It does have this, and I agree, it has this kind of wanky speedometer sort of thing here across the top along with the digital readout. That doesn't really do much for me, but some people, I suppose, probably like that. So let's go ahead and put it on, we're going to measure AC volts. So we have AC volts. This is an auto ranging meter, which means you don't have to set a range. It does it for you automatically, which is convenient for people because people don't usually understand what kind of range to use. And here on the bench today, we have two things powered up. We have a NuTone LBC55 that's been running for a couple days to make sure it behaves itself. So we'll measure the voltage of the power supply for that, and we've got 16.623 volt AC, which is probably pretty close. I suppose I could also compare it to my other bench multimeter, which is up out of the shot. It's up there where you can't see, and that's a meter that costs several $100, more than that, $400. And if we do this, 16.63, so it's the same. There isn't any reason why any kind of modern multimeter, regardless pretty much what you pay for it, shouldn't be pretty much dead on accurate. So then we'll measure our other thing I also have running today on a separate AC power supply, a NuTone L37 clock that I repaired. And we hook up to that, and we've got 17.2 volts. It's kind of jumping around because the connectors are a little dodgy here. 17.23, and that's pretty much what I would expect. I'm going to go ahead and turn on my DC power supply. It'll take a second, and then we can switch this over to DC volts. People have a problem with AC and DC volts. I talked to a lot of people on the phone, talked to a fellow this morning. He has an IM3303 and everything suddenly went dead. And I asked him, did you open it up and did you measure the transformers? And he said, yes, I did. And I said, and what did they show? And they showed no volts, which would be highly unusual. It would be possible, but highly unusual. So the very first question I asked somebody like that is, were you measuring AC volts or DC volts? And then there was like a DC volts. And I think he was guessing. But and it's like, no, they're AC transformers. So you have to measure them AC. So AC, DC. So we'll go ahead and put these over here. It's not turned on. Let's set it to something. Let's set it to 19 volts. We'll do 125 milliamps. Not that that makes any difference. And we'll go ahead and turn it on. And we've got 19.01 volts, which is exactly what I would expect. So we'll go ahead and we'll put in 25 volts. Oh, that was 5. 25. And there you go. The power supply only goes up to 30, so that's good enough. However, what we can do, no we can't, because those are both being used. So I don't have a high voltage source here. I'm going to talk about high voltage sources in a minute. So you watch the meter, and I'm going to go back and I don't have a high voltage DC power source because that's not something we ever use, but we can measure AC high voltage. So what's showing right now is 160-ish millivolts, thousandths of a volt. But if I take the probes off camera here and I plug them into the power strip on the end of the workbench, now we know that we have 116.2 volts on the power strip. And you notice the numbers change from white to red because red is for danger, because it's high voltage and you have to be more careful when you do high voltage because you don't want to blow yourself up, because people tend to do that sometimes. Now, you can also measure resistance with this. I'm not sure. Let me go grab a resistor really quick. And we'll do function 2, which looks like resistance, little omega symbol there for resistance. And I'll sort through my tub of resistors. These are just lots of miscellaneous things that I have here, which you collect after decades. Here's a nice big chunky resistor, easy to see. This is, it's 0.2 ohms. It's a 1% 0.2 ohms resistor. This would be like an emitter resistor for an amplifier probably. So if we take our probes and we measure this, you just put it on the ends of the resistor. It should measure 0.3, 0.26, not bad. So you might be asking, why isn't it 0.2? It's a 1% resistor. It should be like really, really dead on, shouldn't it? Well, you also have to remember that you have, a really low value like this, you also have to factor in the resistance of the leads themselves. If we get a bigger, higher rated resistor, here's another big old chunky one. This is a 20 ohm, 10%, 10 watt. It's a big old ceramic resistor, like a power resistor. So it's 20 ohms. So if we put this on here, it's right in there, 19 point, depends on how well the probe's contacted, but 19.8, it's well within specifications because it's plus or minus 10%. So it's anywhere from 18 to 22 is within tolerance, and that's pretty much what it shows. So that works really well. Also, you can also use it to check diodes. And let me get a diode. We're just making this up as we go here today. So here's a diode. This is 1N4002, probably the most common diode on the planet. And volts, capacitance, okay, so you have continuity. It should beep. Super, super important, super, super helpful when you're working on like intercom systems per se, and you're testing out and measuring wires, looking for broken wires or shorts between wires or shorts in wires or things like that. Continuity meter, your best friend ever. Such a good friend that you buy at lunch every day because it saves your butt by giving you an audible tone. I'm not sure about there's the diode test. So see this little diode symbol there. So if we put the probes on here, and no, I have not read the manual, but it should be pretty straightforward. Nothing that way. And 0.6 roughly this way. And that shows that the diode is good. So diodes have polarity. There's a anode and a cathode. You can think of it as a plus and minus. When you feed a voltage in one way, it'll show the voltage drop across the diode, which is roughly 0.6 volts. And that's what it shows. And when you hook it up, flip it around, hook it up the other way, it'll show over limit or zero. It's not zero, it's over limit. No measurement because the diode is blocking the voltage from going through. And then it also has capacitance. So this is the little symbol for a capacitor. And I happen to have right here some little ceramic jobbies right here that I ordered in for something I'm working on, and these are supposed to be 0.01 microfarad. So if we put this on here like this, it shows, no, it's 10 nanofarad, so it's 9.9, so that's pretty much right on. So that works out well too. This does have a limited range for capacitance, but for small values it comes in really handy. The other thing it can do, and I don't have one here, I don't use a lot of LEDs here, so I don't have one floating around on the bench. When you're in diode mode, it puts out enough voltage that you can light up a red or a white LED to see if it works, so that's very good also. It's a good multimeter. Is it as good as the X-Tech multimeter that I did a review on 6 years ago? Probably, maybe not. Not exactly sure about that, but if you want a combination unit for the money, hard to beat. Now, let's talk about safety for a second. Oh, you can also measure current. You have two current ranges. You have to take the little sticker off here. You can measure a maximum of 10 amps or all the way down into the milliamps or thousandths of an amp range. The reason they have this little sticker right here, which I'll show you, it says, stop testing voltage in current mode, tear off before use. When you are measuring voltage, your probes are like this. When you're measuring current, how much power your device is using, these are not the jacks you use, and you also just don't move this one over here and then hook it up to the power for the LBC55 to see how much power it's using, because you will immediately blow the fuse inside the meter for the current. Current is the amount that's flowing through the leads. It's more complicated. Read the manual. You'll learn how to do that. Because if you do it wrong, you blow the fuse up. You can open it up and replace the fuse, but that's a pain in the neck, so read the manual. Now, I'm going to turn this off now because the battery's getting really low. All right, so meters, or I should say multimeters, have safety ratings. Now this one says it's rated at 600 volts at in a Cat 4 rating and 1000 volts in a Cat 2 rating. Now, if you want to know what the Cat ratings, that's C-A-T and then a Roman numeral after it, Google it, because I'm not going to explain it all to you. But it has to do with how safe the meter is to use when you hold it in your hand on high voltages, like up to 600 volts or up to 1000 volts. It has to do with how the circuit board is made inside the case. It also has to do with how the case is constructed, its sturdiness, and there's gaps that close it off on the edges. And the whole idea behind this is, if you're in, like, say, an industrial application, you're in some big industrial plant or something like this, and you're using this and you're probing some 1000 volt or 900 volt circuit, and if something goes horribly wrong and the thing explodes, it doesn't take your hand off, because those things can and have happened in the past. So the benchmark for safety for multimeters would be something like this. This is my tried and true trusty Fluke 83. Any meter that says Fluke, if it's a real Fluke, not some knockoff thing that you bought somewhere and you don't know where it came from, any one of these, whatever the cat rating on this is, and I'm not sure what it says, it's probably somewhere on the back. We'll take it out of the holster and see what it says. On the back it says, what does it say? I don't know if it does say. Let's take the probes out a minute. 1000 volt max, that's all it says. Okay, it doesn't say what the cat rating is, so you would have to probably go on the Fluke website and see what it was when it was new and all those sort of things. But I've had this for a long time. I bought this when I first started. I bought this like 35, 38 years ago. And I would have no hesitation and no problem with taking this into some high voltage application where you're measuring 400, 500, 600 volts and hold it in my hand and do what I need to do and not worry about it blowing up and taking my hand off. Not at all, because Fluke is well known and highly regarded for their safety in their designs. Something like this, yeah, I don't know. It does have cat ratings, and I assume it's got some kind of certification, but let's see what the book says. It probably has some kind of certifications, but it doesn't readily say, and you probably have to read the whole thing and see if it actually does say. Don't see anything there in particular. Does it say anything on the box? No. So, has it been highly tested to make sure that it meets its ratings? I don't know. Do you want to risk your hand if you're measuring 500 and 600 volts in some test application and you're holding it like this? No, I don't think so. I don't think I would do that because I don't have necessarily that much confidence in something like this. But if you're doing low voltage work, which is really what we mostly do around here, or if you're occasionally doing like I did and taking the probes and plugging it into a wall outlet to see if there's any power there or not, and especially if this is like leaning up against the wall or laying down on the floor or on the kitchen counter, that's okay. You can do that. It's very unlikely that it would ever explode. It's very unlikely you would ever get hurt. If you do, that's on you because you're the guy using it. But for me, anything more than that, no. Mostly what we do around here is all low voltage stuff, so it's under 70 volts. So nothing's going to happen at 70 volts. Not at all. Now we'll talk about the cost. Wait, I forgot. We have a temperature probe. We've got to try the temperature probe. So the temperature probe, I believe, probably plugs in red and black jacks here, like we showed. Let's turn it back on for a second. It always comes up on the oscilloscope screen first. I don't know if you can change that, but if you can, that depends on what you're going to use it for. We'll switch it over to this. And now we need to find temperature. Oops. And I think it's on Celsius. That's all right. Oh, maybe, no, wouldn't be that. I don't know. We'll leave it on Celsius. It does say on the display, it says temperature 77 degrees, which is probably about right. If I take the probe, and hold it in my hand, it should go up. 82, 84, which is 30 Celsius. We're really more Celsius oriented around here. We're Celsius and we're metric, we're millimeters, and because that's all works out better for electronics. So it's 88 degrees. Let's see. 91 Fahrenheit, 32 Celsius. I don't remember what what is normal body temperature? I don't remember. Anyway, a temperature probe is a nice thing to have. The X-Tech has one also, probably a little better than this one. So what would you use this for? Well, you can use it for something really simple. You can take it, and these are like homeowner applications. You can take this, if you have this, and you can put the probe down in your heat register and see what the temperature of the heat coming out is, or what the cool air is coming out at. Because your wife says, I don't think the air conditioning is working as well as it's supposed to, and you can get your meter and you can get your temperature probe and put it down in the heat register duct, and you can wait and find out how cold the air is, because that is one of the things that air conditioning guys do, to see how cold the air is. The other thing you can do is you can take it and put it in your refrigerator and see if the refrigerator, if you have one of those fancy ones with a readout that says what it's set at, and see if it's right or not. You can put it in your freezer. You can do all kinds of things. Temperature probes are a good thing. I've done videos where we put temperature probes on transformers to see how hot they get when they're under dead short. You can do all kinds of interesting things with a temperature probe, and it comes along with it, so that's all pretty good. Now we'll turn it off. All right, so we have a Zowie ZT702S digital oscilloscope / multimeter with all of its accessories and cables and all of these other fancy things that it does, that we ordered when we first saw it because I felt I needed a new toy. And no, I don't buy toys that often. It came fairly quickly, halfway across the road from the New Beautiful Life company, or New Beautiful Life store. And the total cost for all of that, everything you saw in this video, including the shipping, all the way from across the world, was $67.36. Not bad, okay? Certainly much, much less than a $400 oscilloscope. On par with what the X-Tex EX330 costs just for a multimeter. So really, how can you go wrong? And not only all of that, but you get a really swell carrying case to put it all in. So you keep your meter and your probes and all your other things all in one little case. You keep it zipped up. You put it somewhere safe so you know where it is. And when you need to use it, it's all ready to go. I think personally, it's quite a bargain. It's not something everybody's going to use. It's not something everybody's going to need. But here in this shop, I just wanted one. What am I going to do with it? I have no actual idea. I already have 3 oscilloscopes I use all the time. Well, 2 I use all the time. 1 I use very occasionally because it's a really old ICO single trace scope that I only use for certain types of tuner alignment work. But when you gotta have it, you gotta have it. I hope you found this interesting, and perhaps for someone it will be helpful. If it is, give it a thumbs up on YouTube because that helps us a lot. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications. And every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.